All right, we are on our third lesson for Precalculus, doing our review unit. Today's date is Wednesday, October 9th, 2019. Points of discontinuity, very, very useful when it comes to AP Calculus. Who can read our objective? Oh no, no one knows how to read. Andrea, go for it.
Find the zeros, vertical asymptotes, and removable discontinuities for rational equations.
There it is. So those three things, they will help you quite a bit. So when I say 0, can we write this above? This is the x-intercept. You're really looking for your x-intercepts in terms of your graph. So if I had a graph, I could say, I don't know, you can make some weird function that goes like that. Here are the zeros, there, there, and there. That's what I mean by 0. Where's the height? 0. The height is 0 at the x-intercepts. All right, so I copied and pasted the same rational expression in each of these. So you need to circle the one that will give you the 0. And the one that you're going to circle is the one that doesn't cancel out, and that is in the top. Do you see the one that doesn't cancel out and that's in the top?
And that is in the top?
It has to be in the numerator, and it doesn't cancel out. There it is, x minus 7. And then the way that I solve to find that answer is I say, okay, set that equals 0, x minus 7 equals to 0. And once I do that, I add 7 to both sides, and I get x is equal to 7. So at 7, in this rational expression, my 0 is at x equal to 7. So far, so good. Nice and easy. Okay, vertical asymptote. Geostega, what do those look like? Yeah, they go up like this. So go ahead and draw a graph like that. So here's a vertical asymptote. That's not the best. There it goes. Usually you do like a dashed line. You get closer and closer to it. Maybe you have another vertical asymptote that comes up here and then comes down here. And you have a vertical asymptote that looks like that. You get closer and closer to it without actually touching it, and then you go really far in the y direction, either positive or negative. So what causes those types of graphs with vertical asymptotes? It's something that doesn't cancel out, that's in the denominator. Circle that one. What doesn't cancel out and is in the denominator? That is correct. It is x minus 1. And I set that thing to 0. I set the thing in the denominator that is not canceling out, set that to 0. X minus 1 set equal to 0. Shout it out, you get x is equal to, yep, so at x equals 1, I will have a vertical asymptote. So a removable discontinuity, the way that that looks is you have some weird graph, and then all of a sudden, bloop, they did a hole punch, they punched out that point, and bloop, maybe another one. You're just missing a point there. That's a removable discontinuity. A removable discontinuity is caused by something canceling out in the top and the bottom, the numerator and denominator. Shout it out. What do you see that's canceled out on the top and the bottom? There it is. These guys are going to be your removable discontinuity. So I set that equal to 0. X plus 3 is equal to 0. And shout out, you get a removable discontinuity at x is equal to? Be careful. Negative 3. There it is. Cool. So that's all you need to know to do example 1 and the example 2 on the back. So let's do example 1. We need to factor this thing in order to get it looking like the form that we have here. So let's do a ninja star to factor the top. So I'm going to do my ninja star, negative 6 and 1. 1 again coming from the middle term. I need a quiet raised hand. What times what is negative 6? That also adds to positive 1. Fiona? Negative 2 and positive 3. There it is. So let's write it out. X minus 2, x plus 3. Let's do a ninja star for the bottom, the denominator, I'm looking for something that multiplies to -3 and adds to 2. Who can do that one with a quiet raised hand? And Fiona, can I take your card too, please? Thank you. Who can do our ninja star for the denominator? Only Fiona? Oh, James, go for it.
-3 and 1.
Careful. So -3 and 1 will give us a -2. Which one needs to be negative?
-1.
There it is, -1. So I'm going to have x plus 3 and x minus 1. Cool. Now we have it set up very similar to what we have up here. Almost, yeah, very, very similar. All right, so where am I going to get x equal to -3? Is that going to be a 0, a vertical asymptote, or a vertical discontinuity? Or are you going to check one of those boxes? What do you guys think? Quiet raised hand, quiet raised hand. Who's got it? Take a guess. You have a 1 in 3 chance if you're just guessing at random. Eva. You are correct. Why? Yeah, it cancels out here and here. Perfect. That is why it's a removable discontinuity. X equal to 1. Which one is it referring to? Obviously, it's referring to x minus 1. Therefore, is it a 0 vertical asymptote or removable discontinuity? Gio? It can only be 1. Vertical asymptote is indeed correct. And finally, x equals 2. Chris, what is that? X equal to, x is equal to 2, so is that on the top or the bottom or both? Top, therefore it's a, it is indeed a 0. Thank you, Chris. I think Fiona was the one that caught this last year, but what happens if you have, let me give you a weird example. This one will be kind of fun. Please copy it down. What happens if I have x plus 3, x plus 3, and x plus 3? What would x equal to -3 be? Is that a 0, a vertical asymptote, or removable discontinuity? So Fiona probably knows because we talked about it kind of in depth last year. What is x equal to -3? Because you can't be both of them. So you have to choose one or the other. So you have the choice between, well, they both cancel out, so maybe you're thinking it's a removable discontinuity, but then you're kind of left with one on the top after you cancel them out.
0.
Fiona, what is it? 0? It is indeed a 0. Because yes, they do cancel out, but I can still, like, it still causes me to get a 0. So this is a 0. I hope I'm not misteaching you. I only vaguely remember that. All right, what I want you guys to do right now by yourselves is on example number 2, try it out. Factor that thing and see if it's a 0 vertical asymptote or removable discontinuity. After you solve example 2 and you check with at least one other person, then you can begin the homework on Khan Academy. All right, let's go through example 2 really quick. Who can factor the numerator? Quiet raised hand. Teflon.
So I got x plus 2 and x minus 4.
It is indeed x plus 2 and x minus 4. Who can factor the denominator? Who's got it? Sego. X plus 7 and x plus 2. Perfect. So we're all going to shout these out at the same time. X is equal to -2 is a... There it is. X equal to 4 is a... And x equal to -7 is a... There it is. All right. You got them correct. That concludes our notes.